everybody. Oh, it's quite loud, isn't it? My name is Martin Evans, and I'm here to tell you about this underwater ROV that I've built. And I'm going to look at some of the lessons that I've learned building the ROV. And this talk really, it's all about hardware, really. And there's a little bit of software at the end, but we'll just work our way through it. Most people would have heard of ROVs probably from last year with the oil spill that was in the Gulf of Mexico. This is some footage that was taken at the time by one of the inspection ROVs, so you can quite clearly see the amount of oil and gas that was leaking from the pipes. They tend to use ROVs in this role. This was an inspection role. They did use other ROVs for actually when they came to repair the damage, and sort of basically use ROVs where it's going to be dangerous for divers to work, and they're fairly cheap because they can just keep on running. But my story starts 20 years ago, and I worked for a company called Hydrovision, and this was the vehicle that we used to build at that time, and I was worked for them as a student, and this was used in the offshore oil industry I'm sort of based up near Aberdeen, northeast of Scotland. And this was what was called an inspection ROV. All it did was just observe sort of whether welds were done correctly. It could also be used to protect divers when they were deep underwater, just to keep an eye on them, make sure that everything's functioning okay. But what was unique about this was it had a camera, and this viewport, so a perspex viewport, sort of went around the whole of the vehicle. It's sort of like split in half, and the camera inside could rotate for a full 360 degrees, and that was quite unique in the industry at the time. There's two lights on the front, and it had 4 thrusters, which they used for sort of maneuverability and sort of surfacing and diving, and these were those 2 there, and then they had one, there was one here and there was one obviously around the other side. It was quite a neat unit. They used to sort of went offshore quite often. It's no longer made. They sort of tend to be sort of larger, more expensive ROVs, I think, now. But this is where I started, and from that point was when I really wanted to build my own ROV. But it didn't have to pay £1,000, so it's only now with the sort of costs of motors and technology that's brought a lot of the costs down, so it's actually now an affordable project. And then a few years ago I bought this book, which I have a copy here if anybody wants to look at it a little bit later on, a bit more detail. And this was done by Harry Bowman. I think they're from Canada, had to import it. But it's a great book. I mean, it's designed, I think, for kids, a lot of it, but it goes in, or college students, or sort of, I don't know, the upper level of school. They can build these projects. But it's all clearly explained what an ROV is, the effects of pressure, goes through everything. The one on the front is, this is what they call the sea perch. And this is controlled by 3 motors. There's 2 here for thrust and for moving it around. And then there was one here. And the book explains in great detail how to do that, and they actually pot the motors in wax to keep them waterproof. The book's broken up into projects, so you actually make your own underwater camera as well. That's like in a self-contained unit. And the latter part of the book, they have to do something that's called a sea fox, which is the next one. This is an example that was built by this Steve Thorne, and he has a website, homebuiltrovs.com. There's lots of detail on there, how he built this and his experiments and so on. But it's built from, this is mainly PVC pipe from plumbing agents, and that's a method that I followed in my own ROV. But for propulsion, they're using bilge motors that you find on yachts or boats that they have in the bilge for pumping out the water. So they're already waterproof, so you can just use them as they are. Some people take them and you can sort of cut the top off, and they'll actually put a propeller on there, which makes them a bit more efficient. But this is controlled from, sort of uses a tether, same as what I do. And they're very successful. You can just about see, this is actually a small camera unit here, and it's in like its own little box, and that feeds up. And then this is the last book that they've bought. I've not actually seen a copy of this. I've read the reviews. It's very good, but it's something like 700 pages. And weighs about, I think it's something like 3.5, 4 pounds or 2 kilos. But it's supposed to be really good. It's designed for students who are studying underwater robotics, and it goes into great detail of all the design challenges and how they overcome it. Its main aim is at students who are taking part in a project called MATE, and each year there are competitions, and they have secondary schools in Scotland, academies, and the students they have to build an ROV, and this contains a lot of the guidance of how to do that, and then they're then given what do you call it, different exercises to do, and they're then scored on that, and there's like a winning team. But I mean, monetarily, you have people. I mean, you do have people like MIT there who've got huge budgets, and then you've got little schools as well that take part, and it comes down to individual ingenuity. It's not just a case of just throwing money at the problem. It's actually working through the exercises and getting it right. This is a micro ROV. You may have seen them downstairs in the coffee area. This was originally designed by Aberdeen University RGU, Robert Gordon's, and it's produced under license by a company called MadLab, and it's sold as a kit. So you need very basic soldering skills to put it together, because it's the switches that control the thrusters. It has 3 thrusters. There's one. There's one there for going up and down, and then there's one on each side for control. It's a bit like driving a tank, but it does go better in one direction, but that's just the way the propellers are. The propellers are much more efficient when they're sort of pushing away. And it takes probably about an hour to build, but they're quite nice, they're robust. The motors aren't waterproofed in any way, but what we find is as long as you dry them out at the end of the day, an occasional squirt of WD-40 to drive water out and to give them a little bit of lubrication, and they last fine. The 2 that I've got down, excuse me, the 2 that I've got downstairs, the one is about 3 months old, and that's been in and out of the water, and it's still working fine. The other one's much more recent, because we went down to a maker fair in Newcastle about 3 weeks ago, and we took these down with us, and we had a tank, and there was just loads of kids, and they just spent the whole day sort of driving these around. They have no fear at all of what they're doing, and they actually broke a switch, but they were treating it like a joystick. So if you see them downstairs, do have a play. You won't break them. They're pretty robust, and they're great fun. They're quite safe, so it's just 6 volts on the battery and there's the lead that goes down it. This is a commercial ROVs. Well, these are quite unique. These were done, these Jake and Elwood, which I think is from the Blues Brothers, and they are used by, if you remember James Cameron, obviously did Titanic and more recently Avatar, but he's got a great interest in underwater stuff. And these were 2 ROVs that he commissioned to have built, and they were used in a film called Ghosts of the Abyss, where they actually went down to the Titanic. And what was unique about these is that this was a submersible that brought them down to the deep, and then they were in like a garage, and then they were sort of sent out from there. So the onboard batteries for power, but they were controlled by a very, very tiny, thin fibre optic that just spooled out from the back of the ROV. And it was highly manoeuvrable. They actually went into the Titanic and looked all the way around it. And the intention was the fibre optic just kept on paying out. It wasn't intention to actually reel it back in. So when it was finished, they brought it back to the garage, cut the fibre optic and left it there. But what they'd made it was so it was biodegradable. So that after a few years, it would just disappear. So they didn't want to leave anything that was going to be damaging down below. And I mean, they're quite cute in their own little way, but the job they did it really well, and they produced a brilliant film. If you ever get a chance to see it, Ghost of the Abyss, it's really good. And this was an expedition that was done last year. This was done by a company that they more or less own the salvage rights to the Titanic. How they got that, I don't know. But they went back and they used a similar ROV. It was controlled by a fibre optic with onboard batteries. And they've made a 3D film of the Titanic. And they went down and had a look, and I mean, the photography is just absolutely incredible. And the ROV was called the Aurora 6000, 6000 being the depth that it can go down to is 6,000 metres. And this is just some of the footage that they got down there. I think it was August last year when this was. But the Titanic, it's gradually rusting away, and these tend to have what they call rusticles that sort of hold down. And originally the Titanic was discovered by Bob Ballard, and he's been back since, and they've started to document what's happened and they can see bits of the structure that have collapsed. So at some point in the future, it will just totally sort of disappear. But it's broken into two main parts. There's the front part and the back, so it's actually spread over quite a large distance. But some of the film you can see like plates that are still down there, cups. You can see, I think it was the ship's captain's toilet or something in the one bit, and his bathroom. But I mean, the quality of the image is just amazing. Of course, you have to use quite powerful lights to sort of penetrate the depths. And there's not really much sea life. There is sea life, but there's not very much of it. Just to the extreme pressures that you've got, and also there's sort of no light. But I mean, these are just some of the examples that they use ROVs for. Obviously, they use in the offshore industry, used for exploration. They also use them now, of course, with the problems with terrorism. So they actually use them in certain harbours for sort of checking for that nobody's sort of getting up to anything. And those tend to be like very small inspection ROVs. So considerations when you come to build an ROV. You've got sort of quite a few things to think about when you actually do your first planning of what I'm going to do. You've got your lights you've got to consider, because obviously it's dark, or it's, you know, there's not as much light, and it sort of light fades away fairly quickly. So on this one I used diver's torches, which I bought from Lidl, and the other consideration was cost. I mean, cost is always a thing that drives it, so it was a thing to look for readily available parts that are mass-produced, because that obviously drives cost down, and to try and keep specialist bits as minimal as possible. One of the main things you have to think about is power. Now, you have a choice. You can either have a battery on shore, and you drive the power down what's called the umbilical, or the tether, or you can have batteries on board. Now, if you're using your batteries on shore, the problem is that you need a thicker wire, because obviously you have power losses when you're driving the motors, because they draw quite a large current. So that means if you've got a thicker tether, it means it's harder to drag around, because obviously the ROV's got to drag the whole weight of all of that. And the other option is you have onboard batteries, which in this case I went with an onboard battery, which I'll come back to why I made that decision. It was sort of driven a little bit by the types of thrusters that I use. Commercial ROVs, if the oil industry, a lot of them they use sort of down the tether, but they use extremely high voltages. I mean, which something that we can't use as a hobbyist, because it's just too dangerous. But they're a minimum of 240, and in some cases it goes up to thousands of volts for the big work-class ROVs that sort of go down there and sort of move pipes and stuff. The other condition is something that comes up a lot on sort of questions is, will you have a wired ROV, are you controlled by a tether, or a wireless one? And a lot of people think, that'd be a brilliant idea, I'll get a Wi-Fi because that can go anywhere. But unfortunately, the radio signal is very high, the frequency, so the actual penetration through water is negligible, so it's actually not an option to do that. So it then comes down to whether you want a wired ROV, or the alternative is with no wire, which is called an autonomous underwater vehicle. And that is where you'd actually give it instructions to follow a particular path and sort of navigate itself and come back. But I mean, that's obviously beyond our scope at the moment, so we use a tether. What I've used on this one is a Cat5 cable, but it's used USB extenders, which gives me a 50 meter, up to a 50 meter or 150 foot long tether, and which you'll see a lot of sea life sort of go up at 15, 20 meters. You know, that's about the maximum, really. So this one's 30 meters. I've got it on at the moment. At a later point, I will take it up to the full 50, but it's nice, and it's a good size. It's not too heavy to carry around. This was the original parts that I assembled together. I ended up not using all of them, but this was the PVC frame that I'd actually built. That's just made from plumbing pipe, commonly available. And it's not very clear, but this is the hole. It's actually a drainage pipe, underground drainage pipe. And I got the Cat5. This was actually, my original intention was to power it from shore, but sort of considerations later on meant that I didn't do that. So this was actually quite heavy speaker cable, because it's quite heavy duty, but it's reasonably flexible if you get the multi-strand. And there was a few other various bits. This was the frame prior to painting. That's my shed. But it was assembled with you have a choice really. You either use solvent glue to glue the frame together, or you drill and put screws into it. I chose to drill and screw it because it can come apart much easier later on. So if you want to sort of change lengths of things or you want to add things on, it makes that a lot easier to do that. And that was it once it was painted. I don't know why it is, but you have to paint an ROV yellow. It's just sort of the tradition. So this was a buttercup yellow. And if anybody's from the States and you want to do this, they actually sell a paint, I think it's called Krylon or something like that, that actually adheres. It actually sort of partially melts the plastic, so it gives a really good strong coating. But due to health and safety, it's not allowed into the UK. So we use something called Plasticoat, which is reasonably tough, and it does bond okay, but things do sort of knock off fairly quickly when you're sort of manoeuvring it around in harbours or sort of just generally moving things around, paint gets knocked off. But it looks pretty when it starts. Cable glands. So, I don't know if you can see them come off afterwards now. I used to get cable glands initially for all the entry points into the hull. And what I did was I actually glued them in place in an attempt to keep water, because that was the main thing you want to do, is you've got lots of electronics in there, you don't want the water getting in. And so sort of and these are the main points where you can get water ingress through cable glands or anything that's connected externally. And this was the original hull put together. So this is just underground drainage pipe, and this is just the shape it comes out. This was used for joining. So it's 4-inch pipe or 110 mil, so 100 mil pipe. This was actually used for joining two pipes together, but it's a very flexible rubber with what do they call them? Jubilee clips, so you can really sort of tighten that up. And on the front there's a Perspex dome, which I bought a number of years ago, sort of meaning to, this has been a plan that I've had for quite a long time, and I got it from a surplus store in the States. I had it imported over. But there is a UK company that do them now, and you can actually specify what size you want and what the thickness of the material is. This is 3 mil, which is quite strong, particularly in sort of like that sort of shape. It's a lot stronger than having like a flat Perspex, just because of the pressure of water when you get below. And the Jubilee clips are really good because you can just sort of like screw it in really tight. And because it's rubber, it deforms around the hard Perspex, and so you get a really good seal. These things, eBay is definitely your friend when it comes to buying a lot of the electronic stuff. The thruster motors and the speed controllers were all bought on eBay. I think it was like something like £50, which is what, $75, $80 for 4 motors and the speed controllers, which is pretty cheap, really. The camera also came from eBay. Again, it was imported from China. You're looking sort of like 7 days delivery, and I've ordered quite a lot of stuff from China now, and I've never ever had a problem. This is the electronic speed control. It's a basic radio control, electronic speed controller. This one's rated up to 30 amps, which is more than adequate for what we're using here. And it's controlled by this here. This is basically a standard servo controller, sort of a standard servo connection, I should say. And these are just the connectors that for connecting onto the motor. These didn't actually come with it, so you have to put your own connectors on. So again, you do need some soldering skills to do that, but it's not difficult. And this is the bare bones of a thruster. That is a pipe coupling from B&Q, it's 50 mil. And this was one of the motors. And this is what's called a brushless motor. So and the type of brushless motor is an outrunner. So the actual body of the motor turns. And what that does is, because it's got the weight with it, that actually gives you a lot more torque, which is something that you need when you're going underwater. Really, you want sort of fairly lowish speeds driving it forwards, but you need plenty of torque to sort of drive it forwards. And then the propellers were bought from, they're basically just boat propellers. But they have two types, some that run clockwise and some that run anti-clockwise, so that it stops. If you're sort of driving forwards, if they're both turning the same way, it tends to spin the ROV around this way. So you use them so that, say, one's counterclockwise and one's clockwise, and it stops that torque action, so it'll go straight forwards. So that's something to be careful of. So you buy them in pairs like that, and it's exactly the same for the dive thrusters. We do the same thing. And there's the brain, which is the Arduino, which I think is probably is anybody not familiar at all with an Arduino? Not heard of an Arduino? No, I mean it's become, I think, the main microcontroller for building things. It's, due to its cheapness, its expandability, the fact you can add sort of shields to it, and it's dead easy to program. I mean, it comes with libraries that you can just link into very quickly. I mean, last year I gave a talk on it was an obstacle avoidance robot, and that was using Ruby to drive that. This year I haven't actually used Ruby to do this tool. I just did it straight into the C++ libraries. The project we were working on last year didn't. The development sort of ceased on the Ruby application. No, was it saying Ruby Arduino development kit? It sort of seems to have stalled, and because there's new versions of the software from Arduino coming out all the time, and there's a new release that's going to be due out within the next couple of months. It's actually in beta at the moment, and that's actually going to break possibly a lot or some of old code and shields, so they're going to have to rewrite. So they're going to like a version 1, and that's going to be sort of like the feature set that they're looking to go forward with. So they're looking to break some stuff now by sort of trying to make it easier for people to program in the future. I used a servo controller on it. I mean, it's actually an I/O board. You can put your servos straight onto the Arduino. This just makes it easier. Excuse me. Because you've got rows of pins, and so you can just plug it straight in. It's just ease of use. And there's two main configurations on servo controllers. Sorry, on servo on the connector on the back of the electronic speed control, and this will cover whichever type you get basically. So you're covered on that. Using the software from the Arduino, it can control up to 12 servos at a time. But that's what you do. You just sort of send it a servo signal with an angle, and that will control the motor. That's a board camera. You find them a lot in CCTV cameras. It's low light. It's okay. I mean, it was quite cheap, and it's composite video output. I mean, I just pull the composite video straight up through the tether, and that goes to a video digitizer on the laptop, so we can actually see the video. If it's low light, but I mean, it switches fairly quickly from colour, and once the light sort of gets low enough, then it switches to a black and white. But the pictures that I've had from it are quite good onshore. We'll come back to what it's like under the water in a bit. And that's a complete made-up thruster there. This was a mounting that I made, and it's made from 3mm Perspex. And that just goes in I showed you the pipe coupling earlier, and that just glues into there with araldite, so it's nice and firm. And then there's just holes cut in it I did with the jeweler's saw, so it's quite rough and ready, but it works. This is one of the connections you can see. At this point I've got, because it was during the initial testing on shore, these are bare. When I actually went live with it, we actually used heat shrink to wrap around it. But I've used glue-lined heat shrink, so that actually gives you a much better waterproof connection, and that seems to be working really well. And again, that's just a close-up of the connectors. See them separated. And you can see more clearly here, sort of the mounting into the pipe coupler. Most stuff, well, practically everything is sort of held together with tie wraps, so it's easy to move around, maneuverability, and tie wraps are pretty strong. This was, well, that's my dive crew. It's my wife and my son. This was at a local harbour recently, and this was a test to see if it kept the water out. And we had to put quite a lot of ballast on it. Here, and here it was just sort of, basically there were stones in bags, because we put it in and it just stayed there. So we put some more pipes on it, it sort of sank a little bit. So we got a couple of big stones and sank it in, and this was the first dip. That was it just going underneath and coming down. Unfortunately, it leaked. When it was drilling, it's very hard plastic, the hole, and it was really difficult to drill. And I think I cut some chips, and so there was actually, although the glands were epoxied in, so they were glued in, I think there were still some holes that were through, and the actual connectors themselves, I think I had some leakage there. So basically I got some fiberglass kit, the cheapest way to do it, and then made up a resin, and then actually, I've something at the front to be able to see, but I'll hold it up. There's like these little wells, so I just filled those totally with the resin, and then I put tape on the inside so that if any of it came through, it would just hold it there so it wouldn't sort of pour out everywhere. And I also improved the connections by filling them, well, I sort of put a heat shrink, then I filled it with marine silicon sealant, and then I sort of put glue-lined heat shrink on top of that and shrunk it all together, and then actually as a final measure I then put a tie wrap on it to hold it even tighter, and that's worked really well. These, I sort of, turn around, this is just a, yeah, we're all connected. These are proving, so they're not leaking at the moment, but I suspect they may do in the future, so I'm going to go back and redo these. But say, do come up and have a look afterwards, and we'll go through it. So that was it. Ready to dive. Oh, and this was the other. We skipped a few, did I? Sorry. Yeah. Sorry. Yeah. This was, so that was, it sank, but there was no electronics in it because there was always that risk. So when I came up on, Thursday, well, I came up on Wednesday, and Thursday I went to North Berwick, which is along on the northeast coast, and did another dive test there with all the electronics in this time, and sort of got permission off the harbour master, and sort of was directed into this little corner of the harbour to do a test with, and this was just out the back of the car. And that was it, photographs ready to dive. This is some of the video. It's not very good, and I'm sort of working on it, and this is underwater. You can't really see much underwater with this. It was quite disappointing, and that's something I've got to investigate and see and improve that. See if we can get that a bit better. But the harbour does tend to be very dirty and very muddy, and the water was the tide was on the way in at the time, so it wasn't very good. But where we live, we're sort of quite close to the coast, so I'm going to take it in the future, and we'll go off the seashore somewhere on a nice day. It's reasonably powerful, but it's still quite a big vehicle, and the motors could possibly do with being a little bit stronger. But for what we've got, it's working. This was looking towards the future, and I've done all the coding for this, for controlling a Wii nunchuck from an Arduino and feeding it in. And it's great because you've got obviously the control, you've got forwards and back, you've got your left and your right, so that just controls the different thrusters. And then what I've been using is the, there's two buttons on the front, one I'll use for diving and one for servicing. And this is what you use to interface it with, which is a Solarbotics nunchucky, which I've got an example here if somebody wants to look at afterwards. And this is great. It just plugs into a breadboard, and you can just sort of like take your wires off that straight into the Arduino. And you can actually have two nunchucks on them, because you can actually stack another one on the top. And I think it's an I2C device, so you can actually call them differently. This is where I'm at. This is a really rough and ready Macruby interface. And this is more of an indication. My original idea, I was hoping to actually control it using the Macruby, but as the project has developed, it's actually proven it's better to actually have a remote control type device. So this is actually just going to be used as a status, so I can see what the thrusters are doing and whether it's surfacing and diving. Extra instrumentation that's going to go on is a compass. This has been interfaced already to the Arduino. I'm just bringing everything together. And this is a digital compass. I was worried a bit that it might get affected by the motors, but it seems to be doing okay with that when I have tested it. And that will display onto the interface. And then the other thing is an on-screen display, which is the Max 7456. And this is done as a breakout board. And again, that can go onto a breadboard, which I have. You probably won't be able to see it very well, but I have all the connectors on here. So this is the video here, and then I actually have the compass on this side, and then there's just sort of connectors then that go onto the Arduino. And that will be displaying the heading and also the thrusters on the video. So I have that to bring together. I've done all the core code's done, it's just got to bring it back together, bring it all together. And this, is to finish, is a submersible that was announced recently. I thought it was just an interesting thing. It was done by Richard Branson. I don't know if any of you saw the news. They were sort of pushing this. It's just a couple of minutes long. It's they're going to do 5 dives throughout the world, and it's a single-person submersible. And Richard Branson's going to be piloting the second one. What they do if it goes wrong, I haven't the faintest idea, because I mean, if it goes wrong deep down, there's nothing that can reach it in time. But what's unique about it is it's more like a flying vehicle, whereas I mean, most of your standard submersibles and ROVs are sort of like quite clunky, like this. And this is what I'm looking at to do as a future project, is something a little bit more like that, so we can actually fly it around a bit more. I think it's constructed from a mixture of titanium, which is obviously very strong, and carbon fibre. And we're informed it's going to be for scientific purposes. But there's nothing being as manoeuvrable as that to those depths, you know, so it's actually going to be quite unique data that it's going to call back. And so that's designed by a guy called Graham Hawkes, who, if any of you have seen the TED Talks that you can download, he does a talk on that, on flying submersibles and his rationing behind the design. And he has a nice quote in there that it really shouldn't be called Planet Earth, that really should be Planet Sea, because if you think about it, the actual comparison between the amount of sea that we've got and the coverage of the Earth, you know, something like 2/3 is sea. So that was quite a nice little analogy. And this was a quote by Jacques-Yves Cousteau, which I'm going to read out. The sea, once it casts its spell, holds one in its net of wonder forever. And I think that's really true. Once you actually start getting into this and looking at, for me personally, I find it fascinating, all the stuff about to do with not just the technology, but it's the stuff that they find. And you've got people like, say, Bob Ballard and others that are sort of finding shipwrecks that tell us about history. An example is they're looking at, well, they keep on trying to get permission to dive in the Baltic Sea, because the Baltic Sea is very cold, and it's also, there's not much oxygen in it at the lower depths, so it tends to preserve things really well. And they've had some sort of sonar pictures, and they've had some imagery of boats that are sitting down there that are probably 2,000 years old, but the wood is still intact, and that's just unique. So they're trying to get permissions to sort of go down there and explore it in more detail, and it's going to give us a lot more information about us as people, you know, and how we've developed and explore ideas. And I think, sort of from an archaeological point of view, I think it's absolutely amazing. Resources. These are the main ones from, if you want to build your own, these are sort of quite friendly forums. You can ask stupid questions, I do, and you get nice answers back. There's a lot of research going on, people doing things in different way. They put on what experiments they've done, particularly with motors, because there's a lot of sort of debate about what type of motors that you use. I think I must come back to that, sorry. Earlier point about brushless motors and why I've used an onboard battery. There's a lot of debate about the distance from the speed control to the battery, and I think it's something to do because they work on it's actually a 3-phase motor, and it's controlled by the speed controller. And what I'm told is that if you use a battery that's a long way away, it can set up interference and you can actually blow up the speed controller. And some people are saying that, and other people are saying, no, it works fine. But I went for safety's sake, and I've just used a nickel metal hydride battery. You can use lithium poly as well, which is actually inside the back of the ROV. And it's quite fun, because when you actually first insert the battery, it's very musical, because they issue various codes that you can program the speed controller with. And it's almost like a little talk that they have. And then but the safety default is that when power's applied, that they don't start up, so you keep all your fingers. And then you have to give it a 0 position, which sets up them. And once you've done that, you can then issue your servo controls and alter the speed. So that was my decision for that, so sorry for that. But yeah, these are the resources. The home-built ROVs, there's loads of information on there, and there's also a forum. This is much newer. This is the RC groups. That's quite new. And it seems to go in fits and starts. Sometimes there's lots of people are posting, and then there's a big gap, and then there's lots of posting. So that varies. The Yahoo group, Robot ROV, that's been going for quite a number of years now, and there's lots of stuff that you can download there. There's lots of people talking about what they've been doing. And there's also examples of video. There's lots of examples of other people's designs of ROV. And it's a really friendly community, and that is actually quite active. And this is my own blog, and there's nothing there at the moment, but there will be. There's lots of pictures I've got of the actual build process, and I'll be putting more information on. And when we actually get some better video footage, that'll be going on there as well, and also all the code that I've used as part to build it will be going on there as well. So go back there in a couple of weeks' time, and hopefully there'll be a lot more information. And that's me. Thank you very much. Thanks for listening. Questions? Yeah.
What was your approach to the issue of buoyancy?
Buoyancy. Can everybody hear sorry, I don't really know, but so the gentleman's question was, what about the issue of buoyancy? This is full of air, so it's extremely buoyant. And what I do is I keep it positively buoyant. So if we lose control power, it will actually float back up. So it's very sort of slightly positively buoyant. What I do find is, because inside these, they've actually got built-in O-rings, these sockets. So it's like a rubber ring that sort of compresses, and that forms a really good seal. So when I'm actually loading this up, what I have to do is release the Jubilee clip to let air out, fit these properly, and then I have to screw that up tight then. That works really well. Otherwise you sort of tend to, you push one in and the other one comes up and sort of it gets in. It's a bit of a muddle.
So effectively you use the up and down motor?
Yes, sorry, yes, the dive and surface, the up and down motor for control of that. Most of the power, the way that the propellers are done is to actually drive it down. It's more efficient going down, and then the other way, so it's not as efficient, but it will come up anyway. So, but that's the safety point is.
So you put it in the water and just add a bit of weight?
Yeah, and it varies as well, because obviously the salinity of the water alters the buoyancy. I mean, if you're diving in fresh water, you obviously don't need as much weight. And I did find that when I had it in the harbour, I've had it in the harbour in Bodham as well. I found I had to put a lot more weight on it than I did when I went to North Berwick, which I assume is an issue on the salinity of the water there. I mean, I think I've got a brass and a titanium pipe on there so they don't rust. So it's brass and stainless steel on that one. We've also got a big piece of titanium, and I found at Bodham I had to put the big piece of titanium on it to get it to go down, whereas Berwick had to take that off, and it was fine after that. Is that answer? Yeah. So but. No, we don't really have that issue so much with this because nothing's really getting compressed. I think divers find that problem because their wetsuits tend to get compressed, and so they lose some of their buoyancy. So they tend to have a bit more weight to get further down, I think, for the initial part of the dive. But I think for the depths that this is being used at, it's not found to be a problem. So, yeah.
What's the total cost?
Roughly, well, see, if I tell you, then I'll have to tell my wife. realistically, it's probably somewhere between £200–300, something like that. I will be costing it. I've kept all the receipts and stuff that I've used in the build process. The most expensive bits actually is the actual plastic underground drainage. Some of those bits are quite costly, but I've had most of the bits from Plum Centre, and if you speak nice to them, you actually get trade discount, so that does save a fair bit there. B&Q do have some of the bits, but they don't always have them in stock, or it can be a problem, and it's finding knowledgeable staff of what you're actually looking for. But I used to just look for the catalogs and yeah, that piece will do nicely, and they took me around and we sort of found all the different bits, so that's where that came from. It's quite good. I mean, you've got a reasonable amount of room inside. I mean, say do come up and have a look afterwards to get sort of bits and stuff into, and it's also very strong at this. Any other questions, sorry? Yes, sir.
What's the legal thing about putting it in the water? Like, if I want to put it in the pen, do I get arrested?
I have no idea. So the gentleman's question about the legality of using, I think, it depends who controls the water. When I went to, a local harbour, I just throw it in. I'd be wary if I started doing it at one of the main harbours. I think that somebody might visit fairly quickly. But you can always ask the harbour master. They have the ultimate control, which is what I did at North Berwick, because I've not sort of been there before. I went and saw the harbour master. I said, I want to do some experiments. Is it okay? And he was no problem. He actually found me a little space that I could park in. I didn't have as much time as I wanted because the tide was coming in and they were looking to load creels onto some of the boats, and so I had to sort of shift it from that point of view. But most people are sort of interested in what you're doing. You speak to them and they're sort of quite interested. You explain it's not dangerous, or it's not going to be irretrievable. It's not going to cause a danger to the shipping, and they're quite relaxed with that. Obviously, off the coast, you can just use it wherever you want. Does that answer you? Any other questions? Yes.
If you don't speak C or C++, is that a barrier to entry?
No, I don't. No, they actually hide that complexity.
You can come out with the scripting languages.
The way the Arduino IDE is, it uses mainly libraries. It has two routines. It has like a setup routine and it has a loop routine. And the setup is where you set up serial communication or one-off things. And then the loop, it just basically loops through the code. But there's lots of examples of doing things. There's lots of information there. So it's not a barrier, not only C. They try and hide the fact that it's C and C++, so that it's not a barrier to entry. The Arduino was originally designed for art students, for installations. And they realised that it was going to be something that wasn't going to frighten people off, and they wanted to make it easy. I think the quote is, it makes hard things easy, and that's sort of an ethos that they carry through the whole of the development process with Arduino stuff. You have the shields that you can add extra functionalities, like Ethernet shields, wireless shields, driving LCDs.
Have you used like a Ruby API or something?
No, nothing at all, no. So, I just did it straight off the Arduino stuff.
That Macruby stuff you showed earlier?
Yeah, that's a work in progress. I've got to integrate that. I've got the Arduino side of things working, and I've just got to do the integration between that so it can show it on the display, basically. So I've got to finish that off.
In Ruby?
That will be in Ruby, yes. Yeah, but that's just looking at the serial port, basically, and reading what's sent in from the Arduino, and also sending out to the control. The reason that I've used the USB as well, I just want to go back to this, if you use USB for this, is that you can actually program it while it's in I haven't got to sort of take everything out. You can sort of, if you're sort of working away at somewhere, you can actually reprogram the Arduino through the laptop while it's all connected. So if you find that a thruster's not working very well, you can alter some of the parameters on that and make it more efficient. So that's the main reason for sort of keeping it over USB. It probably would be a bit easier to use a serial connection, but for the moment we're keeping that. Once something's more stable, we'll probably go to a serial connection because that'll give me a longer sort of depth operating range. Any other questions? Oh, sorry. One, short one? 30 seconds? Okay.
Just a quick question on, I think the cable is feasible for USB. Is there I don't know the specs on like...
With extenders, straight USB, it's 5 meters. With an extender, with these extenders, it's 50 meters. Okay?
Thanks very much.
Okay, thanks for your time.